Okay, our next lesson is graphing linear inequalities in two variables. For our learning goal, I will graph linear inequalities in two variables. So pretty straightforward. And this lesson should be pretty easy to do. So a linear inequality in two variables looks a lot like a linear equation in two variables. However, it's going to be an inequality. So we're going to have, either a greater than, less than, instead of an equal sign. So to start off with, we're just going to be given some inequalities. So for example 1, let's see. You're given that inequality, and we want to know, is the ordered pair -1, 9 a solution of that inequality? So in this case, x is going to be -1, y is going to be 9. So we're going to substitute those in and see if we get something that's true. So that would be 2 times negative. I want to know, is that less than 3, or -3? So 2 times -1 is -2 plus 9. Is it less than -3? It's going to give me 7. Is 7 less than -3? No. So -1, 9 is not a solution of that inequality. For another one, let's say 3x minus y is greater than 5. And we're going to try the point 3, 0. So when I substitute 3 for x and 0 for y, do I get a true statement? So this would be 3 times 3 minus 0. Is that greater than 5? 3 times 3 is 9 minus 0. Is 9 greater than 5? Yes, it is. So this is a possible solution of this inequality. Now, of course, that's not the only point that will work. There's infinitely many points that will work for x and y. This is just one of them. So that was our first part, was just testing if this was a possible solution. So for example 2, now we're going to be looking at what the actual graph of linear inequalities look like. So to start off with, we need to decide if we're going to have a solid line or a dashed line. We're going to use a solid line when our inequality is greater than or equal to or less than or equal to, because it means any point on that line is possible, so it's a solid line. Whereas if it's just greater than or less than, we're going to use a dashed line because the points on that line will not be solutions. It's kind of like when you decided between an open circle and a closed circle on the number line. The same rules apply. So to start off with, let's just graph an easy one. We can graph y is less than -1. So in this case, think about what the graph y equals -1 would look like. Remember, y equals -1 is going to be a horizontal line because we're going to have a slope of 0, and it's going to go through this point right here. So I'm going to do my graph the same way that I would if this were an equation, except for in this case, this is just y is less than -1, which means my line needs to be dashed. So hopefully you can kind of see that. I drew a dashed line right there at y equals -1. And then it's not just the points along that line, but my y can be anything below that line. Or if I think about it, if I put in the point 0, 0, there's no way to put x in, or there's nowhere to put x, but if I put in 0 for y, 0 is not less than -1. So 0 is not on the shaded half of my line. So any point in this region right here is going to be a solution of this inequality. For example, if I pick this point right here, this is 2, -3. My y value is less than -1. So that's true. That is a possible solution. So this graph was pretty easy to do. Our vertical graphs are going to be similar, where if we have just x is greater than or x is less than, let's try and graph one of those. Oops, that kind of showed up. So let's try and graph x is greater than or equal to 2. So this is going to be a vertical line, because if you think about what x equals 2 looks like, it's going to be the line that looks like that. But in this case, it's x is greater than or equal to 2. So now, there's 0, 1, 2. Because it's or equal to, I have a solid line that I'm going to draw. And now I need to shade in the side that's greater than 2. So like here, x is 3. 3 is greater than 2, so this is on the shaded side. So this whole region is shaded. Basically, everything on this half of my graph would be shaded. And any point over here would be a solution of that inequality. For my next example, I want to graph 2x minus y is greater than or equal to 1. So what I am going to do this, I'm going to just think about the line 2x minus y equals 1. And I'm going to figure out what I would do to graph this line. So I would subtract 2x from each side. So I get negative y equals negative 2x plus 1, and then divide everything by negative 1 to make it positive y. So y equals a positive 2x minus 1. So this would be a line with a y-intercept at negative 1 and a slope of 2. So y-intercept at negative 1 and a slope of 2. So up 2 over 1, up 2 over 1. So as far as the actual graphing, the line part goes, I just think about it if it were an equal sign instead of an inequality. But before I connect those dots, I look back at my equation and I see that it's greater than or equal to. So that tells me it needs to be a solid line. Remember, if it were just greater than, I would do a dashed line, but because it's or equal to, I'm going to draw a solid line to connect those points. And that would cover all of the points. That's not a very good line, but that would cover all of the points on the line. Now I need to decide which side of the equation am I going to shade. And my favorite thing to do for this is to just plug in 0. So try the point 0, 0. If 0, 0 makes this true, then the side containing 0, 0 is shaded. If 0, 0 makes it false, then I would shade the other side of the line. So I'm going to substitute 0, 0 into my equation. 2 times 0 minus 0 is greater than or equal to 1. That's 0 minus 0. Is that greater than or equal to 1? Well, no, it's not. So that tells me don't shade the side with 0, 0. Shade the other side of the line. So any point on this half or anywhere over here is going to be a solution of this inequality. My final example is a word problem. You can spend at most $24 on party supplies. So that at most is telling me we have an inequality. I don't have to spend $24, but I can't spend any more than $24. So you can spend at most $24 on party supplies. Party hats cost 50 cents each, and helium balloons cost $2 each. Write and graph an inequality for the amounts of party hats and balloons you can buy. Identify and interpret 2 solutions of the inequality. So let's say let X be the number of hats you buy, and let Y be the number of balloons you buy. And of course it doesn't matter which is which, but you need to identify that first. So I know that I can't spend any more than $24. So the amount that I spend has to be less than or equal to 24. The amount that I spend on hats is going to be 50 cents times the number of hats that I buy, or 0.5x. The amount that I spend on balloons is going to be balloons that I buy. So this is going to be the equation that I'm going to graph. Now, I need to actually draw the graph for this. And when I do that, I want to be logical about it. I can't buy a negative number of hats. I can't buy a negative number of balloons, so I don't need negative numbers on my graph. So I just need positive axes. So let's see. I can buy, I'm going to figure out my intercepts. This is kind of like a standard. This is standard form if it were an equation. If I had 0.5x plus 24y equals $24. Oops, that should be 2, not 24. So 0.5x plus 2y equals $24. If I put in 0 for x, y would be 12. So 2, 4, 6, 8, 10, 12. If I put in 0 for y, x would be 48. Let's see, 4, 6, 8. 34, I don't quite have enough room, so let's count by threes. 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, there's 48. So there would be my x-intercept. So what I'm doing by drawing this line or connecting the intercepts, and it's going to be a solid line because I can spend exactly $24. So I draw this solid line. And what I just created, this entire region right here is all of my possible combinations of balloons and hats because I don't have to spend $24. So the next part said identify and interpret 2 solutions of the inequality. So like this point right here is a possible solution. This is where my x is 6 and my y is 6. So 6, 6 would be you buy 2 hats, or I'm sorry, you buy 6 hats, you buy 6 balloons, and you've spent less than the $24. Or you could pick this point right here, 27, 4. That means you bought 27 hats and 4 balloons and you spent less than the required amount. Or I'm going to pick another one. This is on the line, 24, 6. If you buy 24 hats and 6 balloons, you'll still be within the requirements of spending less than or equal to $24. So this one was pretty easy once we came up with the equation. Of course, you could have turned this into slope-intercept form and graphed it using slope-intercept form. I just thought it was easier using the intercepts. Yeah, so that's all there is to it for this section. So basically the whole idea, you're graphing just like you would graph a line, but then you have to decide which side of that line is shaded in, and you also have to decide if it's going to be a dotted line or a dashed line or a straight line. Solid. So that's all there is to it. Good luck.